Hey, good day, future engineers. Uh, let's have our final example for this specific topic on the curvilinear motion and rectangular components. So, okay, for our last example, we have a particle here. We have a graph here, the x and the y, and then we have our origin. Oh, the particle travels along the path defined by the parabola. If the component of the velocity along the x-axis is vx is equal to 5t, and then the unit is feet per seconds or foot per seconds, determine the particle's distance from the origin and the magnitude of its acceleration when time is equal to 1 seconds. Take note that the time is equal to 0, our x is equal to 0, and y is equal to 0. Okay, let's list first what were they given. So we have here an equation of the path again. Y is equal to 0.5 x squared. What is another thing that were given to us? We have the equation of the velocity of x, which is equal to 5t. Take note of the unit that is in foot per seconds. What's up again? We are also given that the time is equal to 0, the position along x is 0, and y is equal to 0. And we were asked to find what is determine the particle's distance from the origin. So that is r. And the magnitude of the acceleration. So that is our a. At time is equal to 1 seconds. Okay, so we have a. Therefore, we need to differentiate velocity para makakuha ta acceleration. So we can get acceleration. And since na-unlike position here, we need to integrate also velocity so we can get a position. So what are we gonna do? Let's say atong first button is we would like to get r. So the magnitude of the r is just equal to, since this is just two axes, the x and the y, that is just equal to x squared plus y squared. So we have our y is equal to 0.5 x squared. Now, and then we also have our vx is equal to 5t. And we know that vx is just equal to dx over dt, which is equal to 5t. Then dx is equal to 5t dt. We integrate this one, that we will have our position function along x, which is equal to 5 over 2 t squared plus c. But ingon siya at t, at the time is equal to 0, x equal to 0. Then safely we'll have our x is equal to 5 over 2 t squared. So may next na to buhaton. So we need to find the r. We need to find the r at c is equal to 1 seconds. So masolve na nato x is equal to 5 over 2 times 1 squared, that is just equal to 2.5 foot. How about cy? Y is just equal to 0.5 x squared. You just substitute the value of x, that is 0.5 at 1 second, 0.5 times 2.5 squared. Then we will have, or we can find the value of our y is equal to 3.125 feet. To get the r, you just extract the square root of the x squared and y squared. You have here 2.5 squared plus 3.125 squared. And we have the magnitude of the position of the particle at 1 seconds is equal to 4.002 feet. Next, we're going to ask the magnitude of the acceleration at time is equal to 1 seconds. Okay, so we need to take note of our equations. We have also this one and this one. Okay, so we have Vx is equal to 5t. To get the acceleration along x, we just differentiate Vx with respect to time. So that is, so the derivative of 5t, and we'll have the acceleration along x is just equal to 5 meters per foot per second squared. This is in foot per second squared. How about the ay? We have our y is equal to 0.5x squared. Our vy is equal to, we have the 1, or just the x times dx over dt, or x vx. And our ay is just equal to x times the vx again. Don't forget that vx is 5t. We'll have 5t times x. So we will have x times 5 plus 5t times dx over dt, or 5x plus 5t vx ay. So as Tuang solved earlier, we have that t is equal to 1 seconds, x is 2.5 feet, and also the velocity along x got actually it was already given 5t, that is equal to 5 foot per seconds. So we'll have the acceleration along y is equal to 5 times 2.5 plus 5 times 1 second times Vx is just equal to 5. And we'll have that our acceleration along y is equal to 37.5. 37.5 foot per second squared. As we already have our acceleration along x and along y, we have the magnitude of the acceleration is just equal to the square root of the square of the acceleration along x and the square of the acceleration along y is equal to 5 squared plus 37.5 squared. And we can solve that our acceleration is just equal to 37.832 foot per seconds squared. So, mo lang siya, iyan na siya kadali si kung ano si curvilinear motion and the rectangular components of the particle moving in a curvilinear motion. So, take note, we have our position R, and then it can either be a vector quantity or a scalar. We only have the magnitude. For the vector quantity, for our R vector, we have the xi hat plus the yj hat plus z k hat. And for the magnitude, that is just the square root of x squared plus y squared plus z squared. Now to get the vector velocity, we just differentiate the vector position with respect to time and along its component. And to get the vector acceleration, we just also differentiate the vector velocity with respect to time along its component. And to get the vector, the magnitude of the velocity, you just start the square root of its components, no? Same also with our acceleration. Kaya na lang. Okay, that's all for our curvilinear motion, our rectangular components, and I hope you learned something. And please feel free to message me if you have any questions with this.